Newton's third law of motion. In the beginning, we recall that as previous video, the third Newton law of motion as m object and m capital object which has distance between both objects is L, which L, because it's about distance, we can define L as norm of displacement between M position and M capital position. But in this system, we don't really care about L value, which because L may be very large as approach to infinity or very small approaching to zero, but still it needs to satisfy norm or generally metric axiom. And now if we make a dot line or dash line between both M and M capital, we label this dot line as interaction with response time interval as t. So that means by recall the definition of impulse, we will have the integral from 0 to t, which is as time interval, which now initial time is set to be 0 as starting point to send signal, and the upper bound of t tell us about response is received, which is both m and m capital receive response of interaction. So by taking the integral f with respect to t and by definition of f by momentum vector, we will get that the result of this integral is about difference between momentum vector at t and at t is equals to 0. And now we see that in this system, the force applied is only about response from both objects, as Fm vector is force from m response and F vector m capital is a force from m capital response. And by rewriting those vectors as magnitude multiplied by its direction, we will get as this summation. And by the interaction, we know that each other interaction have different in direction but same magnitude for both force. That's the essential of third law. So that means we will get the final result of total force is equals to 0 vector. And according to this result, this means that difference between momentum vector is equals to 0 vector, or we can denote this as p vector I at initial or t is equals to 0 is equals to p final vector or momentum vector at t in this system known as momentum conservation. And then we have an interesting concept that F vector m and F vector m capital is conservative force if the total force F vector m plus F vector m capital is equals to 0 vector, which is in momentum conservation equation I denote before interaction and F denote for after interaction. In this definition, interaction may be collision, electromagnetic, gravity, and etc. So that's how third law of motion tell you about motion. We know that why the third law generalize the second law, because the second law doesn't tell you about interaction, but in third law told you about interaction and how physical objects in our physical system behave just like in nature. So I think that's it for the video. Be sure to share, like, and subscribe, and see you later.